Okay, so we have two individual assignment 1 and individual assignment 2. Individual assignment 2 will share with you by this week, is in your UFuture, and make sure you go to UFuture and then download the instruction regarding individual assignment 2. So it is also Excel exercise. So make sure you know how to do it. And I will show you a glimpse of how to actually do the assignment 2, share with you just to guide you how to do the assignment 2. And then also I will share with you regarding the group assignment. Okay, so for group assignment for this week, what you could do is you can already choose your group member. Okay, let's see how many group member that you need to choose. Assignment. Let's see. Okay, so group assignment 5% lah, alright? 5, not more than 5. The minimum is 4%. Okay, so I've not shared with you the instruction yet, but what you could do is right now choose your group member 4 to 5%, and then put the names and the group in the WhatsApp group, our WhatsApp group, our Fin534 WhatsApp group. Okay, meaning that for group 1, how many percent, group 2, how many percent, group 3, how many percent. Okay, so that what you could do by this week lah. You put in our Fin534 WhatsApp group, and then you put your group 1, group 2, group 3, and then by the time I will share with you the group assignment this week, you read the instruction, and in the instruction, of course, you need to choose the company, or you choose the banks, or you choose the organization that you want to do the analysis. It's also doing analysis but using Excel. So what you could do is you put those names, okay, because it is a first come first serve basis. So if you already selected the company or organization, then you need to put it in the WhatsApp group under your group name. So this will avoid other groups to use a similar group. Okay, so that is not the same. So that is what you could do by this week. All right. So there's two things I'm sharing with you today, which is one is the individual assignment number 2. Okay, we have the second individual assignment, and then the another one is the group assignment. Okay, so these are the two things that you should do lah. And then later on, the due date is by 30th of May lah for individual assignment 2. Okay, for group assignment, do you need to do presentation? You need to do what do you call this? Video presentation, if I'm not mistaken. But later on, I will check again, because for you guys, you are what do you call this, online, right? Previously, we do it face to face. So I'll check again. Is either you do video or you will do the live presentation, meaning that it's online lah, but you have to do it present. So it's either you give the video, but of course I prefer the video lah, because when you do the video, it's much more manageable. Okay, sometimes there is technical issue, especially if you want to do online presentation. So once you do video presentation, you already upload it in YouTube. So YouTube is just depending on the line. So once you share the YouTube video, it's much more clearer and much more better lah, actually. Okay, so that is what I prefer. But never mind. Later on, I will tell you again when I tell you. Maybe I'll tell you next week. but I will share with you the information already lah by this week. Okay, so that is a group assignment and also individual assignment number 2. Alright, it's not yet uploaded yet. I will upload the instruction after the class lah. Okay, any question regarding group and individual assignment?
No, sir.
Okay, don't have. Alright, so if not, then we proceed to our class. Okay. Um, I'll just share with you what is the group assignment all about. The individual assignment number 2. Let me see. Let's go to assignment. Sample assignment. Okay, so right now I'm sharing with you the individual assignment number 2. Okay, hopefully you can see it on your screen right now. So this is assignment number 2, and there are 4 questions. So these are the types of questions that you need to do lah later on. And then you do it like how you do individual assignment number 1. Okay, it's the same format, the same way how you want to submit it also later on. Okay, and here is more to our previous chapter, which is hypothesis testing. So we've been through chapter 5, statistical inference, chapter 4, descriptive statistics. So it's very related and associated with those 2 chapters. So in order for you to attempt this individual assignment number 2, you can refer to those 2 chapters, and of course, if you have other alternative of reference, you are welcome to do so by referring to those reference. Of course, you have YouTube videos and so forth. So that will be a good way to refer. Okay, maybe I'll share with you certain videos that will assist you in actually doing this 4 question. All right. So I'll just show you the first question. That means from here you already have extra mark. Question number 1. Okay, so this question is regarding binomial distribution. Binomial distribution. So meaning that when you do a graph and there is a points, okay, points in a graph whereby that will indicate what are the recorded data from this new advertisement that they made in order for them to know whether each customer has a probability of making a purchase. So in that distribution, you will know what are the chances, the chances in percentages that will actually encourage the potential customer to buy. Is it more than 5? Is it around 5? Okay, depending on the percentage of the outcome from the binomial distribution analysis that we are going to do after this. All right, so let's take a look at this question. Okay, we read this question first. So Mita, okay, Mita is a very famous brand, right, in Kuching, selling butter cakes. So they are considering in doing advertisement for its new butter cake. Okay, it's more to R&D about the advertisement. So suppose that each potential customer has a 5% probability of making a purchase. Okay, 5%. That means if the customer look at the advertisement, there is a 5% probability that he or she would actually buy the butter cake. So here the instruction says in a separate worksheet, that means what you do is you can go to another worksheet. Okay, you create worksheet. What you do, what I prefer lah, you can do is you rename it as question number one. Okay, question number one. Okay, back to the question. Uh, in a separate worksheet, construct a binomial distribution for 20 potential customers and find the probability that exactly 5 out of the 20 potential customer will actually make a purchase. Of course, we cannot make, it's quite difficult unless you know the formula of how to do it manually. But of course, thankfully, we have this Excel. So Excel already have the function tab for binomial distribution. So maybe we can go here nearer instead of going to the next worksheet, right? Okay, so what we could do is you enter, you press equal sign. You type binomial distribution. So binomial distribution, the short form is binom.dis, binom.dis. So you click it. Okay. Then you see the numbers, trial, probability, and cumulative. Cumulative distribution. So to make you understand it better, what we do is we go to this function tab on the top left hand side of your screen. You type this small fx function, and then you go to binom this. Okay, you search binom this. Okay, binom this. Okay, what are the numbers? So the numbers is 5. 5. What is the trial? The trial is 20. Okay. And then probability is 0.05. Okay, here. 0.05. Is it true or false? Okay, so here beneath this formula builder, you can actually refer to what does binomial distribution mean and each of those boxes means. Okay, so you can refer that what numbers is the number of success in trial. Okay, so we want to know, is it 5 out of 20 would be the success. Okay, and then trial is the number of independent trials, so 20 is the independent trial, 20 potential customer. Okay, and then we have probability, the probability of success on each trial, okay, which is 0.05. Okay, so each of these 20 customer has a potential of actually making the purchase for how many? For 5%. And then what is the cumulative? Cumulative is a logical value for the cumulative distribution function, and we use true. For the probability mass function, we use false. So for this instance, we use true. Okay, so after that, now you have the answer already, 0.99% lah. Okay, done. Right, so there's 99% chances that there will be exactly 5 out of 20 potential customer that will actually make the purchase. Okay, there may be 5 or less lah, 99%. There will be 5. Okay, so that is what the question and what is your answer will look like lah, right? Okay, so this is the first answer for question number 1. Okay, free marks for you. right? Of course, question number 2, you have to attempt by yourself lah. Question number 3 and question number 4. 2, 3, and 4 is mainly based on hypothesis testing. So you have to look back at our session previously, and also if you still don't require assistance, you can always look at YouTube and other references, or you can always ask me in the WhatsApp group. Right, so that's regarding your individual assignment number 2. Okay. All right. Any question? Don't save.
Not yet, Doctor.
Okay. Not yet. Hopefully later on, once you know how to do it, you are more than welcome to ask me later. All right. So now we proceed with our where is the slide? Let's find the slide first. Okay, we basically finished chapter 5. Now we go to chapter 6. Wow, chapter 6, 70. Okay, so take a break for a while. Then we continue at 11 o'clock, right?
Okay, sir.
Okay, so let's continue on with our class for today. So I'm going to share with you the slide for share screen, share entire screen. Okay, let's go here. All right. So today is regarding chapter 6. Okay, chapter 6, trend lines and regression analysis. So previously we learned about descriptive statistics, whereby we need to uh, get hold of the mean, the mode, and the average, and we actually record it in the table form, so that's easily to also understand, right? But that is only in the numerical functions. And after that, we go to statistical inference, whereby you need to use and correlate with each of those types of data that you have gathered before. And now we're going to trend lines and regression analysis. This is the part whereby that I've been always mentioning to you, right, about the plant and how does the plant relate to each of these IV from the DV, the dependent variable and the independent variable. So when we see a trend line, what uh, when a dependent variable is going up, what will happen to the independent variable? Okay, does the independent variable actually influence the directions of the outcome of the dependent variable? So this is what interests us in chapter 6. So chapter 6 will actually help us to know whether we would like to actually create a visually more attractive statistics. Okay, normally statistics, sometimes we only um, let our viewers look at our analysis by only referring to the numerical data, okay, in numbers. So sometimes the numbers tend to be a bit boring. So what we do is we try to um, let the audience, the viewers, or the anyone who is going to read your report remember it and understand it better. So what we do is we create this chart. It's either can be a trend line chart or a bar chart. So from this association of analysis variables, okay, we either can collect this data from one single year, okay, or from different companies in one single year, or one company in multiple years. So there are two types of how we would label this type of concept. So for example, for cross-sectional data, we use a scatter chart, okay, many samples, list for countries in Asia in one time, 2020. For example, Asian countries, in Southeast Asia, we have a lot of countries, right? We have Malaysia, we have Indonesia, we have Singapore, we have Thailand, Brunei, and all the other Southeast Asian countries. So all the Southeast Asian countries are the data, and the data is only gathered from one particular year, which is 2020. And we shall label this as a cross-sectional data because you only gather from many data from one point in time, one point of time, which is 2020. Meanwhile, for time series data, we will create a line chart. Okay, a line chart, which actually will tell you what is the performance, what is the trend, okay, by using the trend line in, let's say, in uh, 10 years. For instance, you use one sample, which is Malaysia, one country only, but you want to compare it by multiple years. So from years, we already label it as time series data. Okay. So these are the differences when we want to do research, when we want to do analysis, we would say it's either we use cross-sectional data, which is multiple data in one point of time, or we want to use time series data, which is only one data for multiple number of years or point in time. Okay, so there is a YouTube video that you can refer to better understand visually what does this cross-sectional and time series data means, right? So in order for us uh, to create the association between the dependent and the independent variable, there is a mathematical formula that can assist us in actually uh, draw a picture on the chart. What do I mean by draw a picture on the chart? It means that when you have this mathematical, or what do you call this, a formula that will assist you in actually plotting the graph on the chart. Okay, so each of these point on the chart is the representation of the formula that is being used. Okay, of course we have linear, we have logarithmic. Okay, yeah, that means you just use log to get the the answer, or you use polynomial, whereby there is another extended variables. Okay, for example, we have plant, right? We have plant, which is the y. The dependent variable is the y, and then we have the independent variables. Okay, so these independent variables are the extra information that is needed for you to actually plot the graph. Okay, for example, if you just only have water and you have a constant, that means you use linear. When you have more than other independent variable that would actually uh, influence the growth of the plant, then you would add on the soil and uh, the the fertilizer. Okay, so these are polynomial second and polynomial third order. Okay, and then of course we have the power and exponential. Okay, so these are the types of uh, equation, okay, that you can use in order for you to create the or plot the graph. So in the end, when you plot each of the points in the graph later on, what does it show you at the end of the day? Will it show you an upward trend, a downward trend, or a binomial distribution, or a U-shaped graph? Okay, so that is what we think, what we can do to consider at the end of the day, right? So at the Excel, if you go to Excel, okay, which can escape first. Maybe we can try one of these. Let me share with you the Excel first. Stop presenting. 5, 3, 4. Okay, so I've just shared with all of you the Excel for you to practice in the WhatsApp group. Okay, so now maybe we can try open one of it. Ooh, nice. Okay. Share screen. Share entire screen. So in the Excel, what you could do is you have a data sheet first, and in order for you to develop a trend line, either from which equation that you are interested in, can refer to this format trend line. Okay, so Excel trend line, where to find it? Insert trend lines over here. This one. This is spark line, pivot chart, recommended chart. Let's see. Right click on data series. Let's see. This one. Where is it? Oh, I forgot already. Let me get back to you later on after this regarding the trend line tools. I think you have to make the table first before you could actually do this trend line. Okay, so in order for us to do this, we need to have the chart so that we can display the R squared value. Okay, so R square, what is R square? R square is the measure of the fit of the line to the data. So when you actually plot the graph later on, the R square will show you how close are the points with the line that will shape the entire plotted points within the chart. So if the closer the points with the line, that means the R square will be actually closer to 1.0. Okay, it could be 0.9 and so forth. So that will indicate that the points is almost true lah. Okay. So here we can see that from the equation, y minus equals to negative 9.5116 and then plus 20512. Okay, so that's the equation. So x is the one on the x-axis. So every points in the x-axis later on, the data, for example, I think it's could be price or demand. So you will put that points in that equation. So it will actually generate the points within the chart later on. So that will indicate if it's nearer to the line that is 0.8. We can see that when the R square is 0.8, that means the chart is not, there's not a lot of outlier, not a lot of suddenly data that is so far away from each other. So 0.8 indicates that here we can see that the value that is closer to 1.0 indicates that all the points are perfectly fit. Okay. So for this one, this is not a straight line. It just follow the what you call this, the points. But if you were to draw a straight line, we can see that maybe it's somewhere between 0.6 or 0.5, okay, because or 0.7 lah, 7 something, or near to 0.8, okay, because you can see that there is not much outlier. Outlier meaning that, okay, maybe in 2007, May 2007, there's suddenly a spike of price that goes up until 140, or there's another uh, outlier that in December 2007, the price suddenly dropped drastically to 20 ringgit, $20. So that is will shift the R square from a closer number to 1.0 to maybe a smaller R square, maybe to 0.6 and so forth. All right. So if there's a lot of outliers, that means the R square will be lesser. Okay. So these are the types of equation in order for you to actually develop the R square. So if you were to choose the exponential, then it's 0.6. If you were to use the log, it's 0.3. If you use polynomial, 0.9. If you use the third polynomial, third order, you get 0.928. And if you use power function equation, you get 0.3. So based on this selection of equation, of course, you will refer to polynomial third order because it gives you the largest indication of best fit, which is 0.928. Okay. All right. So for regression analysis, okay, regression analysis, this is regression analysis, all this while that we are looking at, because we want to know the association, okay, the relationship between the dependent variables to one or more independent or explanatory variables. It could be in the form of ratio or categorical, of which are numerical. Okay, for example, we have sales, which is the y, and will equals to the independent variable of price. Okay, price. And then the second independent variable will be the income. And then the third independent variable will be the location. So what does it mean here is because we want to know what affect the sales. Okay, if we were to look at the real world situation, the sales, right? So sales during festive season, like Hari Raya, like Gawai is coming soon. So you will notice that the price, normally the price will go down, right? This one, they want to attract people to those who are preparing for celebration of festive seasons. They will intend, they will tend to buy a lot of things. So in order for them to attract, they will reduce a certain amount of value of the product, goods and services, including the price. So we want to know whether lower price will actually affect sales. So okay, then we include the independent variable of price. Of course, we have a lot of types of price. Okay, price. It doesn't mean that only one particular goods. We have a lot of data, right? So we can include all the prices inside the equation. And then the second one will be the income of your buyers, right? Because when you distribute survey form to your customers, right? So they will actually answer lah, tick or give a Likert scale. So this one is more to open-ended question, or they can just tick lah. So normally maybe 1,000 to 2,000 ringgit, or some respondent will answer 3,000 to 5,000, 5,000 to 6,000. Okay, and then of course you have different types of numbers of people who will actually answer those questions. Okay, so that will actually influence the direction of the sales later on, the relationship. Is there a strong correlation between the salary that is received by your potential customer towards the number of sales that will be uh, sold during that particular festive season. And then of course you can also add in location, okay, location. So actually then you would, in your mind, you would ask, okay, how can you actually um, make location has a numerical value, okay? So another thing to consider is, okay, because location, right, when you distribute the survey form, uh, your your customer will answer the survey form and then location, okay, then sometimes they will put where do you stay, maybe your question is where do you stay, or where do you buy that particular uh, products, from which branch, okay, location. Okay, maybe this is regarding Maidin, right? So maybe they will answer, from which branch did you bought this location? Did you bought this product? So location could be Kuching, Miri, or Tabuan Jaya, or Samarahan, or Matang. So it depends on the location. But then again, location is words, right? It's not numbers. So how can you quantify uh, in words into numerical numbers that would actually contribute in finding the number of cells that will actually correlate or influence the direction of cells from the word study. So normally what we will do is you convert it into codes. Okay, codes, coding. So coding in numbers. So once you have the coding in numbers, then of course you do not calculate it lah. It's quite, it will be a very hard challenge for you to calculate it manually. So what you can do is you use Excel, or you use different type of software such as SPSS. Okay, you have eViews, you have Stata, and nowadays you have Smart PLS and R, so forth. So these are softwares that can actually assist you in trying to find the relationship between the dependent variable and also the explanatory or the independent variable. Okay. So we have two types of regression here lah, that we can see. One is simple linear regression. Another one is multiple regression. Okay, so we can look at the video. I think I have a video to show to you regarding this regression. Okay, let me choose this first. Is it here? I think. Okay, there's this YouTube video explaining about linear regression model. Hopefully you can you hear? Is there anything? Can you hear the video?
No, sir.
No. Why? Let me see. Share screen. Can you hear?
Still no.
Still not. What happened? Okay. Hmm. Use your phone. Report a problem. I'm not sure so how to actually share. Oh, oh, now I cannot. Safari menu, settings. Oh, now I cannot share already. What is wrong? Okay, never mind. What I can do is I share the content with you. Okay, this one. But you can actually look at it in the YouTube. Okay. Oh, now I cannot share the slide. Even though I went to the Safari file, settings, Google Meet, screen sharing, ready. I think we we end the meeting here lah, because I cannot share the video and not the video, the slide already. Something I pressed something, I think.
All right, sir.
Okay, so we continue on for next class for the chapter 10, chapter 6, and we stop at slide number 9 for regression analysis. And then for next class, we continue on with simple linear regression. Okay. Okay, that's all for today. I will share with you the recorded sharing session for this class.